Hi there, hope you are doing well. In this video, I'll be talking about the properties of the solutions of acids and bases, including the strong and weak acids and bases, the tendency to carry electric current, and then pH and hydronium with hydroxide concentrations in each of them. The simulation is represents here. So the existing uh, amount is the water in the solution. We have got 1 liter of water, and guys, as you know that the water contains hydronium and hydroxide. So the pure water contains hydronium and hydroxide equally. So in a process we call as a self-ionization of water. We'll be talking about this in the coming chapters. So the self-ionization of water is what is two water molecules. They react to produce hydronium and hydroxide. As you can see, the water solution has a pH of 7, and let us change for the pH paper or the pH color keys. The color turns to green, and you can see that the greenest color in this region is 7. So the color of the litmus paper or the pH paper changes to green, represents the concentration of hydronium and hydroxide in water solution are equal and water is neutral. And in terms of conducting electricity, the water is uh, somehow extremely weak electrolyte because of having low amount of hydronium and hydroxide in its uh, the container. So as you can see, the light is not switched on because it's extremely weak electrolyte. So let us change to the strong acids. The change to the strong acids. As we can say, we can see the strong acids. For example, its pH is 2. So the pH of the strong acids are almost approaching towards 0, 1, 2, 3. And so the pH of the strong acids, they have a low pH, and as you can see from the simulation, it has a high amount of hydronium and low amount of hydroxide. So in the solution of the acids, uh, we have existing hydronium and hydroxide, but which one is more? What I mean hydroxide here, the guys, this should be anions, but it acts as the same as bases. So it has the same as to say hydroxide or anions. The anion represent the base, and the hydrogen represent the acid. So the concentration of the hydronium is higher because it's strong acid, but still we have anions as well, bases. So the hydroxide also exists in this solution. Let us, we know that the pH is 2. How about by litmus paper or the color indicators? It's almost in the region of that region that has the same color of 2. And in terms of conducting electricity, it's a strong conductor or strong electrolyte. It has a high tendency to conduct electricity. As you can see, the bulb sparks. It's strongly working, switched on as we can connected the bulb to the solution because it's a strong electrolyte and has a high concentration of hydronium and an ion in the solution. Let us change for the weak acids. Weak acids, the pH of the weak acids above 3 usually. So this weak acid has a pH of 4.5, as you can see, 4.5, and the concentration of the hydronium compared to the strong acid is much lower, so it produces the hydronium, but most of the acid remains as non-ionized molecule. So as you can see, the non-ionized molecule stays here as non-ionized, but we have got fewer hydronium. The reds represent the hydronium and anion as well. So in the aqueous solution of the weak acids, uh, the concentration of the weak acid itself has the highest concentration, and then followed by hydronium and anion. So the existence of both hydronium and anion, the ions in total, and the weak acid exists. That's why the most of the acid remains non-ionized. It's partially ionizable molecule because it has low tendency to ionize. Its pH is much more than the strong acids. And in terms of adding uh, the pH paper, it's almost in the range of the 4.5. As you can see, this range is a range of the 4.5 and has the color of that range. In terms of conducting electricity, guys, it's a weak conductor of electricity. As you can see, the bulb sparks switched on, but is not strong as the strong acid. Let us change for the strong bases. Strong bases. The solution of the strong base, the bases they have high pH, and the pH of this strong base is 12. Usually above 10, it becomes much strong alkaline solutions. So it's 12, and as you can notice that the hydroxide concentration is much than the cation, which is represents the acid, like the hydronium. So the hydroxide concentration increases, that increases the alkalinity of the solution, and the pH as well increases. If we add pH paper into the solution, you'll get almost the color of 12, something like that, almost the 12. So in terms of conducting electricity, the strong bases, they're strong electrolytes. So as the strong acids, they conduct electricity well, and as you can see, the light sparks as the strong acids. For the weak bases, the weak bases, they have the same property as the weak acids in terms of conducting electricity and having the concentration of ions. Here we have got the hydroxide and cation, but the hydroxide is much lower than the strong bases. So the pH is almost lower than 12, should be lower than the pH of strongest. It's 9.5, 7, 8, 9, 10. They are the ranges of the weak base pHs. So uh, as you can see, it has a 9.5 pH due to of having much lower concentration of hydroxide. So as the hydroxide reduces, that reduces the pH too. Thermoconducting electricity, it's not a good conductor of electric current because it has a low concentration of ions in its solution. So these are simply the acids and bases, strong acids and strong bases with weak acids and weak bases. In terms of pH, the colors, hydronium and hydroxide concentration with the conducting electric current properties. We have got the other solutions like the salts and the alcohol with the sugar, but it's not represents in this simulation that guys, the salts, usually we have got four types of salts. The salt is neutral. If the cation and anion comes from strong acid and strong bases, you'll get a neutral salt. The acidic salts, if the cation comes from a weak base and an ion from a strong acid, you'll get a acidic salt. And basic salts, if a cation comes from a strong base and an ion from a weak acid, you'll get a basic salt. And the salts that can be uh, acidic, neutral, or basic are those that cations and an ion comes from weak acids and weak bases. It depends on the Ka and Kb of the salt. In that case, through the Ka and Kb, you'll be able to determine the types of the salt. For the sugar and alcohol, guys, the sugar and alcohol, uh, the salt is in terms of conducting electricity. Sorry, guys, they are strong electrolytes because of having high concentration of ions in the solutions, and all they dissociate to form ions. For the sugar and alcohol, they are polar, they dissolve, but they do not form ions. That's why they do not conduct electric current, and they do not be able to carry electric current. Thank you for the attention, guys.